Hello everyone, in this video I'm going to discuss the example for function and graph. Given we have the function fx which is equals to 5x plus 1 and the function of hx which is equals to 5x squared plus with the 10x plus with the 1. Find the function of gx such that where we have the hx which is equals to f rho g. So can you substitute the situation? We have the 5x squared plus with the 10x plus with the 1 which is equals to f rho g. So f, we have the rho g function gx. So kindly substitute the function gx into the f. So where we have 5g plus with the 1. So that is the situation. So on the left hand side we have 5x squared plus with the 10x plus with the 1. Rewrite the situation. So we have the 5g which is equals to 5x squared plus with the 10x. So gx is equals to, we have the x squared plus with the 2x. So kindly refers to the situation. We already find the gx, express the gx in the form of standard form. So meaning that we have to completing the square. So gx is equals to, we have the x square plus with the 2x plus bracket square minus bracket square. So in here we have the 2x. So meaning that 2 over 2, 2 over 2. So rewrite the situation, x plus with the 1 bracket square minus the 1. So that is the standard form. Refers to b. Hence, sketch the graph of the function gx and based on it determine the existence of its inverse and its possible domain. So what we have to do now is to sketch the graph for the quadratic situation. So number 1, we have the shape U shape because the a is greater than 0. Step number 2, we have the function gx is equals to x squared plus with the 2x. So in order to find the x-intercept, meaning that when y equals to 0. So where we have x bracket x plus with the 2 equals to 0. So x is equals to 0, x is equals to negative 2. So we have the coordinate 0, 0, negative 2, 0. Continue. Find the y-intercept, meaning that when x is equals to 0, so y is equal to 0 as well. So here we have the coordinate 0, 0. Step number 3, we have the standard form. So gx is equals to x plus 1 bracket square minus the 1. So we have the minimum point, negative 1, negative 1. Then we have the symmetrical axis, x is equals to negative 1. So kindly refers to the graph. So refers to the situation where at first we have the 0, 0. Then we have the negative 2, 0. So negative 1, negative 2. So write the situation. We have the negative 2, 0. Then we have the coordinate 0, 0. Next we have the minimum. So here we have the negative 1, negative 1. So the coordinate negative 1, negative 1. Then we have the symmetrical axis. So x is equals to negative 1. So kindly sketch the graph where we have the quadratic. So gx is equals to x squared plus with the 2x. So that is the graph for the function gx. Determine the existence of its inverse and its possible domain. So does the inverse exist? So making use of the horizontal line test. So meaning that draw a line and notice that we have 2 intersection points. So it cuts more than 1 point. Then we can say gx is not 1 to 1 function. So G inverse does not exist. So that is the situation for this part. Then state the domain so that the situation become 1 to 1 function. So we have 2 answers. Domain for G would be refers to the symmetrical axis, prefer on the right hand side. So the domain will be negative 1 until positive infinity. Or the domain would be left hand side, negative infinity until the negative 1. So I prefer the right hand side. If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.